Well, gentlemen, we're here today to discuss changing out your tube in your amplifier, your Ameritron, your Henry, in this case Dentron, and that tube happens to be a 3cx1500a7 or 8877. This is military designation. You will find on your amplifier that your grid meter, which this amplifier doesn't have unfortunately, but does require the tube, your grid meter is your most important unit of measure that you can possibly have on your amp. If you have your amplifier tuned out for maximum amount of peak power and you look at your grid meter and it's slowly starting to work its way up, it usually means that your tube is starting to go bad. The grid meter goes up, output power goes down. It doesn't matter how you tune it, you're not getting any more out of it. And that grid meter keeps climbing. It's usually a pretty good indication it's time to stop and let's think about buying a new tube. So you get on a Goobly Goo and you start looking at the three different companies that bring in tubes into this country, and you'll find that they're not all the same. Richardson's, being a powerhouse that it has been for, well, forever, is going to sell you an incredibly expensive tube. It's going to have the name like iMac on it, or Greenstone, or something like that. A lot of you guys are going to go look at this company. I have a lot of faith in Penta. These guys are a huge company. They've got several different divisions. One's a car division. Another one is a RF engineering division, where they have a whole suite of engineers that travel around and keep equipment running. And the other portion of it is the import and sale of tubes. The reason I like Penta Labs over, let's say, RF Parts or the other companies is that they offer, one, a warranty, and two, they actually test their equipment. When I first started working with Penta, I explained to them that what we're looking for is tubes that are high pot tested and are filament tested and might be built to a little bit higher standard than the rest. They said, well, we can easily achieve that. So these tubes here have been high pot tested, like double their operating voltage, and they sat in the test equipment for a long period of time. That's the way every single piece of equipment that comes out of Penta is certified. I've sold 15s and 20s, 10s, I don't know how many 3500Zs that we've worked with them on and had 0 failures. Now, the warranty comes with some strings attached. These are some pretty smart people. They do RF engineering for a living. So if you order a tube from them and you're abusive to it, like you put too much plate to it, or you drive the holy bejesus out of it, or on and on, when you send the tube back, they're going to be able to tell. They are going to know what happened. You're not going to be able to BS your way out of it. Now let's say you get the tube, you install it in your box, and you have some problems, and it's obviously, it points back to the tube. They're going to stand behind the tube. But you've got to understand, every single thing that comes from Penta is tested, to the nines tested. So the chances of us sticking this in here, taking this tube, putting it in here, and having a problem are almost 0. They stand behind their stuff. If you guys follow these steps that I'm going to show you in this video on how to replace your tube, 1, you're going to significantly decrease your ability to electrocute yourself, and 2, you're going to provide yourself the highest possible chance of success and not having to take your amplifier to somebody like me to get it repaired because you made a silly mistake. Let's get this pulled out of the way and let's talk about what we got to do here. So high voltage safety is just a lot like gun safety. The firearm does not care if it is pointed at you, the kids, the dog, whatever. You have to always be cognizant of what you're doing with it. And the same thing with high voltage. The high voltage doesn't care about you, your house payments, your kid, your dog, your wife, your responsibilities, your grandbabies, your car payments, any of that. It doesn't care anything about that. All it wants to do is find its way from the top of the tube or out of the power supply back to cabinet ground. So we're going to go over this slowly and make sure you guys hear some of the stuff that I have to say. That way nobody can get hurt. Okay? Always, always, always treat a high voltage circuit like it is energized until you know and have demonstrated to yourself, you, the user, that it is not. The simplest way to achieve this is to, one, make sure that the device is off, and two, it is unplugged. Believe it or not, the simplest thing, I've had kill a couple people that I know and some friends that I've had. And I say have had, because they're not with us anymore. And they died horrifically in lots of pain because they didn't follow those first two rules. I had a gentleman with an 8877, bought an amplifier from a gentleman that built the piece of equipment for him. There was no safety interlocks, no fuses, no glitches, no nothing on this piece of equipment. And he didn't think the piece of equipment was running right. So his solution was to open the lid, stick his hand inside of it, and try to adjust things with the equipment on. That meant the blower was on, the filament was on, the high volts were on, the plate voltage was on, and he proceeded to put his hand right on top of the tube. Shockingly enough, when he woke up in the hospital 4 days later, because his wife was in the other room and listened to this sound come out of her husband, to which she had never heard before, and so she immediately went in to go check on him. Now, just by chance, when the high voltage grabbed him, it pulled him in, but the way his arm was situated, he hit the cabinet and fell off and fell over on the floor. Most of the time, it'll cause your muscles to contract and it's going to pull you into the piece of equipment, and you are going to sit there and cook. Now, let's say, heaven forbid, your wife or your life partner or whatever comes out and they proceed to put a hand on you to try and pull you off. Now they're part of the electrical circuit too. So I say, let's treat this with the utmost respect, and let's pretend, not pretend, know that what's in here can hurt you if it is present, but if it's not present, you're perfectly safe. And the easiest way to start this process is to unplug it, make sure that the power switch is off, and then all of our meters read 0. Now, we do not trust this meter until we can verify what it's showing us is true. In most commercial built pieces of equipment that are sold by major corporations that have insurance and liability, there are certain safety standards that are built into all pieces of equipment like this. The Dentron, its safety switch is back here. If the cabinet is not on this thing, this switch allows the rest of this not to be energized, right? On Tentex, they have a shorting bar. On some Ameritrons, they have a shorting bar. Ameritrons usually got dual interlocks. They'll have a shorting bar in the high voltage to where if you lift the lid, the armature will fall down and short against the high voltage. And on top of that, when you lift the lid off, it also will activate, usually on this side of the cabinet, a little micro switch, and it'll make sure nothing can go to the power supply. Those two things are there to help try and keep you alive. A little micro switch on the back corner is to make sure that this is disconnected. The little shorting bar that's on the inside guarantees that the high voltage has gone to the case. We have the same thing in the SB220, the Drake, the Henrys, the Collinses, all of those things. They are there to try and keep you alive. Because once you take that shield off, and if this thing is still plugged in, you're very close to getting to meet God and it hurting the entire time while you die. So the amplifier is off, it is unplugged, the meter says you're at 0. Are you really at 0? Don't know. How we find out is I like to use this. This is called chicken stick. Okay, it's a long, long piece of virgin Teflon. This has a very high dielectric resistance to it, otherwise it's a very poor conductor, and I'm very careful about what I do with this chicken stick. I don't let it get exposed to oil, I don't drop it, I don't drag it across any of the metal surfaces, I don't want scratches on it. This is my life, right? It bonds to the case of the piece of equipment, and then we go in here and we lay it across all the high voltage components. Okay? We do this to make sure there's no stray high voltage. The chances of that are almost zero. Now, a lot of you guys aren't going to have a chicken stick. I understand this. I really do. I get it. I get it. This is my job. This is a field I work in. So, what most guys will do, the old timers will do, is they're going to use a screwdriver. Let's talk about our common household screwdriver for a minute. If you choose to do this, I pray to God you're smart enough not to use one with a wooden handle. Okay? Use something with a plastic handle. This is not my favorite tool for this job. If I'm in a pinch, I like to use this one. The handle's not quite as beat up. Now we know, because we just de-energized it with the chicken stick, that your piece of equipment is not, it's de-energized. This thing's de-energized. Yours, you don't know this yet. These handles, to be sold in the American market, have to prove to an independent lab company that they can handle up to 600 volts worth of insulation. That means that you can take this screwdriver and touch it on something that is conductive, and from here to here is 600 volts worth of insulation at its narrowest point, which is here, right here at this neck. This thin little distance has to be able to vertically, off the center conductor, that would be the shaft of the screwdriver, has to be able to maintain a minimum of 600 volts worth of insulation. All right, so the more distance that you can put between yourself out here on the end of the handle and this center shaft, the better off your chances are of not getting shocked. Our meter says that we're at 0. I have always been a proponent of, when the meter's at 0, still don't trust it, because there could be, the meter could be off by a couple hundred volts. There could be a little bit of stray voltage in there. We touch to the edge of the cabinet, and then we go to the tube, and we let it sit for a second or two. Any of you that have ever played with high voltage in your life, you'll notice that sometimes you can short the cap out, or and that's what we're overcoming, is the electrical charge that's stored inside these electrolytics. You short the circuit out, and if we don't leave it there for a second or two and just pull this away immediately, sometimes there's a little bit of leak voltage that's left inside these caps, and it'll slowly work its way up. It can. Don't trust the bleeders in the high voltage supply. Make sure things are dead and grounded, and when they're dead and grounded, they're dead and grounded. Okay, so we have our amplifier unplugged, our safety circuits are engaged, we have the thing shorted out, and it's not dead and grounded until you know it is dead and grounded. So now we're grounded to the case, and while we're in here working, this is, in some people's opinion, overkill. In my opinion, what's a little piece of wire to help keep you alive? Now we can reach in here and we can go to work safely, and we don't have to worry about anything. Theoretically, the bleeders do bleeder things. Those are resistors that are down here in the power supply. Please note, now I can put my hands on everything and we're totally safe, because this thing is disconnected, because it's off. Our meter shows it's off. We've neutralized the circuit appropriately, and we can now go in here and touch everything. The bleeders are resistors that are held across the top of the filtering circuit in the power supply, and they help keep the high voltage down to a minimum to keep the caps discharged. This is a safety precaution, this piece of wire. Now that we have this thing completely isolated and shut down, now we can go in here and change out our tube. This is an old iMac. This is a great old tube, and there's absolutely nothing wrong with this tube, but we're going to change it out for your guys' cinematic enjoyment and knowledge. So we very carefully take our suppressor, our harmonic suppressor, which is this resistor, and our anode clamp, which is this little ring. We very easily disconnect it. We reach in here and we give this just a little wiggle, a little bit of tension, and we just walk it back and forth and it will slide out. As you slide the tube out, what we're going to take note of is the position of these pins. This big pin is our marker pin. This is our orientation pin. And we're going to set this tube aside. Let's go over and let's open the package with the new tubes. I am putting on rubber gloves, not to protect the tube, but protect the tube from me. Okay. On some glass tubes, it's probably a bad idea if you put your hands on them and touch them. The 3500Zs, they don't get hot enough for that. For a lot of years, we were all told don't touch these with your bare hands. Your hands have oil on them, as we all know. Everybody knows this, basic criminology. We've been taught this since day one, since we were in science class. We have oil that's on our skin. My hands, if you didn't notice, my fingernails are a little bit black and around. I just did an oil change on my big ass diesel truck I've got. And let's face it, diesel high mileage oil is a little black and it stains everything it touches. So we're doing this to protect the tube. People's hand oil on certain things can cause glass to have high temperature spots on it, like certain kind of light bulbs, old incandescent high watt light bulbs. Your oil from your fingers will cause a hot spot on the glass. The glass will get hot because the thing is a vacuum. The glass will nipple in, it'll bow in a little bit and cause a vacuum leak. We're doing this because this tube is virginal and these are going to become my bench tubes and I don't want them looking all nasty in 6 months or a year. This is what a little bit of moisture will do to all silver plated things. I have stuff that has come in here that has been virginal, and once you take it out of the box and you start to touch it, you've started the oxidization process. Well, I want to try and keep the oxidation process. There we go. I want to try and keep this as clean and virginal as I can. When you open up your box from Penta Lab, which is going to be superbly overpacked, you're going to get yourself a born-on test sheet. Looks just like this. Our filaments were 5.5 volts, our filament current was 11.83, our anode voltage was 2,500, and the anode current was, well, just shy of half an amp. These were tested back in October, the 24th of October in 2023. So this tube has been sitting for a little while, almost a year. The guys at Penta have been cool enough to wait for me to do this video for them, or a video associated with these tubes, for quite some time. Let's go ahead and we'll remove this superly overpacked foam beautiful goodness. That is the way things should be, in my opinion. Vacuum anti-static packed, just like this, with a nice cover on the end of the tube to protect the pins. I want you guys to understand that this name on this tube in good working order is worth more than the amplifier in today's market. What Penta is trying to say is, well, maybe that's not the case. Maybe we can provide you a very good high quality set of tubes that isn't going to completely break your bank and your wallet. This is, if this was new, unused, old stock, is probably a $2,500 tube. And where are you going to find that $2,500 tube? If you're lucky, maybe Richardson's. Most guys immediately turn to eBay for whatever reason. I would never buy tubes off eBay. The only time I buy tubes off eBay is to buy them for dud cores to have them rebuilt. You can put anything you want on eBay, anything you want, and label it any way you want to. What I'm talking to is the guy that's thinking a little bit more with their head and understanding they want to get a new product from a reliable company. And that's what you're going to get with these guys. Let's move this incredibly valuable piece of equipment out of the way. And let's grab this incredibly valuable piece of equipment. And let's pop the seal. Wow, this isn't something that's put on at the factory. This is a little bit of love and care that Penta is putting on the tube on their end. So that means they're getting these not in the plastic wrap, obviously. They're loading them, they're testing them, and then they're putting this cap on, and then they're vacuum packing them. That's cool. This cap is made in Erie, Pennsylvania, right here. That's neat. So here's our tube. You'll see that our serial numbers match up with our paperwork up here. Our serial number is stamped right here on the anode head. See that? This thing is great. So let's install this in the amp. This is about the easiest portion of this whole process. We're going to take and we're going to remember where our indexing pin is at. That's this one, the bigger one. And it was up into this corner. I'm just very carefully walking it around. When the index pin lines up with the appropriate set of holes, it'll want to go. Nope. There we go. And we're in. We're applying firm pressure all the way around, evenly on the top of the tube. Evenly, all the way around the tube. Our tube is in the socket. Technically, we're done with this step. What I'm going to talk to you guys about next is pretty important. Now, depending on who you talk to, this next step is not needed. To me, it's needed. This is a base stem of a 3cx1500a7. I keep this around for conversation pieces, and when I actually, once in a while the local ham club will ask me to come do a lecture on something, I will actually bring this kind of stuff with me as a visual aid. See all these different pieces of material here on the bottom of the tubes? These are called getters. What the getter does is it heats up and it expands. The molecules of the getter expand, and after they've pulled the vacuum on the tube body, they will insert the tube into a magnetic heating element, which will specifically heat these pieces up and cause them to glow orange. There's still trace gas that's inside the envelope of the tube. For a lot of years I thought, why would they burn the gas? They don't burn the gas. There's not enough oxygen or nitrogen or anything in here to support an actual burning process, but that's what people call it. It's called the burning in process. These absorb the nitrogen, they absorb the oxygen, they absorb the helium, they absorb the little stuff that's still floating around inside of the tube to help get the tube closer to an absolute vacuum. That vacuum is the highest insulation that we can possibly perform or achieve on the inside of the tube. Well, let's say that we don't light the tube off for 10 years. The little bits of gas that have been absorbed inside the getter work their way out of the getter. and they start floating around on the inside of the tube. And over enough time, that can cause you to have a short. Just a little bit of gas. That's all it takes is for us to have a short. Now, the getters will not stop it if you have a leak. If you have a leak, there's nothing that you can do to it other than you're going to have either the tube rebuilt, or in this situation, they don't rebuild this style of tube. They just don't. What I'm going to show you is the burn-in process. According to some, this is absolutely not necessary. According to me, it makes me feel comforted inside that I know for a fact that I have done everything that I can physically do to keep this thing from having a failure and allowing me to achieve the ultimate level, which is called success. So right now, we've installed our new tube. And if we were to lean back in here, we'll see that we still don't have anything attached to the top of the tube. We want to leave it like that. And now we're going to start to remove our safeties. We're going to come in here, we're going to remove this wire. And then we're going to find our lid. And we're going to reinstall our lid. Just like so. Let me get the lid installed and we'll be back. So health and safety is first and foremost here. We've done our safety brief, we've done our risk assessment, we've done our mitigation to minimize the amount of risk, and we've observed that possibly that the tube definitely does not, because it's made by Penta, but could have been sitting for quite some time, and that we need to go through this next step. So this is also referred to as degassing, burning in, startup, all that kind of stuff. We have our tube installed. All of our safety circuits are back in place. Nothing else is hooked up to this, nothing. We have our high voltage anode lead set off to the side and not touching lots of space all the way around it, so we don't have to worry about it shorting against the cabinet or shorting against the top of the tube. The idea is that we want to let the filaments heat up, bring some tube temperature up inside the tube, and now we're going to turn our amplifier on. Perfectly safe. Now it's going to go through its warm-up process, which doesn't mean anything to us. As we all know, the 3cx1500a7 or the 8877 has a 3 to 5 minute warm-up time before you can put it into operation. All this is doing is letting the filament turn on, settle, and the environment inside the tube settle. Well, we're going to take that to another extreme. We're going to go and we're going to leave this now. We're going to let this thing sit with just filament and air on it for a good 3 or 4 hours. Why do we do this? Well, as the filaments heat up, they conduct a little bit of heat to the getters. The getters absorb that heat energy and they start to expand a little bit, and that gives the opportunity for any other trace gases that might have worked their way out of the getters to resettle onto the getters and get absorbed by the getters inside the tube. This portion of this is critical in my mind. According to some, it is not. In my mind, very important. Let it cook. So it's been a few hours, about 4. Went and shipped off a bunch of stuff. Went ahead and shot another YouTube video on some other stuff. Edited a video, processed it, got it up on YouTube. And now it's time for me to finish this up. So as you can see, we shut the amplifier off and the tube's just been cooking. Filament's been on, air's been blowing. That's all we did. Let it sit in this particular setup, in this particular configuration for about 4.5, maybe 5 hours. You really don't need to do anything more than that. This is just a safety step. Now, depending on who you talk to, this is absolutely not necessary or absolutely is necessary. To me, I like to err on the side of caution. What's a couple hours of letting the tube sit inside the amp with the filament running, no high volts, no high volts, and letting everything inside the tube stabilize? It's nothing. It's a little extra step, can't hurt nothing. It definitely ain't going to cause no more problems, and it might, depending on where you got your 8877 or your 3cx1500a7. Depending on where you got it from, that tube might have been sitting for a long time. If you bought it from the guys at Penta Labs, you could probably slap this thing in here, let it run for a few hours like we did, and you're good to go. We're almost down to 0. When this gets down to 0, we'll go ahead, we'll pop the top. We're going to neutralize everything. We're going to isolate everything just like what we did before, and we'll go from there. So we're all isolated, neutralized, and that kind of thing. Tube is still warm. That is good. The whole idea behind this exercise is that we want to create the best environment that we can possibly get for this tube for its success. The high voltage is the killer if there's any kind of gas or any kind of trace molecules on the inside of the tube. It will cause us to have all kinds of down the road problems, especially if the tube is new. Why not take a couple minutes and let's do this safety test? That's all it is. So all we did was reattach the anode, the tip to the anode. And now we're going to go ahead and we're going to resecure the lid. So for me, this is the scariest bit. Our lid's reinstalled, all of our safety interlocks are now back in place. We're going to go ahead and we're going to plug in our amplifier and we're turn it on. That's the scariest bit to me. If the tube does have a short in it, it's going to show up either when you first turn it on or when you first step on the foot pedal. A lot of you guys have your radios hardwired to your amplifier. I understand the convenience of that, but in this setup, we want to not put any input power into the amplifier just yet, but we're very close. Once the operation light comes on, I'm going to show you what we're going to do next. Okay, so our ready light has come on, and we know for a fact that the tube can insulate itself at about 1800 volts. And we know for a fact now that it can insulate itself at 2500 volts. So instead of being hard on the tube right out the hoop, we're going to sit here and we're going to let this come back down to this 1800 volt rest point. We're simply just going to step on the pedal. There is no coaxes attached to anything. We're not trying to tune and load nothing. There's nothing hooked up. It's just the amplifier sitting by itself. Step on the pedal and we're going to take it into transmit. The transmit light's going to come on. And we're looking at this needle. If there's a breakdown or any failure on the inside of the tube, this needle is going to go tink over to the corner. So we'll go ahead, we'll put this in operate. That's a beautiful thing. Put it up in high volt setting. It's a beautiful thing. If you can achieve this with a little bit of grid current, it tells us our bias is set up, everything's happy. We're going to watch our plate voltage drop just a little bit. That means there's a little bit of a load on the unregulated supply. And there's no arc, no spark, no bang. You're good. Go ahead and hook up your coaxes and have fun. Hopefully this helps somebody. Gentlemen, I want to say thank you to Penta for sending up these products for us to be able to look at, for me to be able to use as a demonstration tool for all of you guys. Big thanks out to Siglant, XS, Bird, MechMan, Coaxial Dynamics. But really, honestly, let's thank Penta Labs, for trying to fill this hole in the amateur market for all of us. Because the 8877 3cx1500a7 is the most ubiquitous tube in amateur radio. And we now have a very stable, solid, good place to be able to go buy these tubes from. Remember, the warranty is only good as long as you're not abusive to the tube. Gentlemen, I thank every single one of you. If you have any questions or anything else I can do to help you out, don't hesitate to give me a call. The number's right there on the wall. I return all calls in the order to which they are received. I do not do phone calls on the weekends or after hours. On that note, so gentlemen, I appreciate you once again. Big shout out to my Patreon supporters. Thank you for helping us make this all possible for everybody on YouTube land. That's all of you guys watching. On that note, I'm out of here. I'll see ya. Clack bang, boom diggity, later, bye. Click, click.